Okay, testing. I hope it works. We will ask somebody online if they can hear us.
No, we're going to do it today. Just like a short intro. I mean, it's...
Because there is also like two more people that might join, but maybe also not. So then we have some spots. Yeah. It's not
It looks like a really good set. Unless if you want to do it from right here, make you do something. Just draw the screen. On the screen. Take a few pictures from right here, then do the recording from right here.
It's streaming, but still watching.
So already invited the
Maybe there, the person. But maybe it would be nice to record in person. Because this TV. Wow, can somebody try how to plug these things in? Here it is. It's covered today.
Really?
Yes.
So you don't need.
So we have a donation from Claros and a couple of more Amigos.
Okay. So you don't need the.
But if somebody can donate for next time,
You know, encourage him to donate.
we have to pay each time 1,500 for every session, and we want to make it open and free for everyone. So if somebody can cover the costs for the rent.
So you still want the print?
No, it's separate.
Okay. Okay.
No, this one. I think it's not that good.
So
Yeah, if you can prove it would be great, but I don't know how. I'm not thinking this one. Maybe if we just like film the room. Ah. But how do we have the presentation slides in? I mean, no matter what, slides are not very serious. So what? Slides are not very good. Okay. You can't see because of the sun.
But I just
Oh, maybe we can.
Yeah,
And you can record
true.
the screen. Maybe this is actually what people try to understand. But we need, okay, we need
This is kind of nice.
All right.
Perfect.
Wait, now we have to review it.
Great, now we're done.
但是我跟
I'm still recording from here, but the live stream makes no sense.
All right.
马上最后一个然后它还有一个就是说有 editor，就是 smart contract，然后它可以做这个，然后这样子帮他去美然后 section。
So who's going first?
I don't know.
对，然后画面其实就它的扣就很简单，它就是这样，然后
Share the link to the Twitch.
You know?
Can you? Have you ever used Twitch?
还不是很
Any of you guys use Twitch before to live
别
stream?
的去拼凑。
So you go to somebody's account and maybe this is
I think on Twitter you can prepare yourself for live streaming. Or
它还没有
Thank you very much on twitch.tv/wizardamigos.
开始 left in 5 minutes. 5 minutes left.
Manage.
Share your screen. Not everyone needs their own. Yeah, because not everyone will have the weird sound.
Okay, let me tweet and then did somebody did anyone check our Wizard Amigos group Telegram chat?
what about it?
For speakers coming out. So that was a mistake. I said like we were 30, like 2, and then we started to 30.
That's good. That's point.
This was the thing, you know, but then I shared it over.
可以 image for the
Huh?
we are for the rest of day because we are just only people say left.
Yeah.
So now I think there is one guy from Switzerland that said he would like to share something. He might come and quick. And if they're not here by 1:30, then we will start, I guess. I was hoping some locals would join because we did like the high version also. We end up to translate, but I mean, I know, a little bored because it's so weird. Next year.
ones, yeah, you have the same quality, but still they are worse. So we're trying to figure out a way to do even something small, just to do it Zoom something like that to get out the video, because otherwise it's way louder and you get like a little bit mic, a machine mic, and have to do it quite fast. So you can make it work anything on there. That's how they usually produce it. There's some final editing tool which can equalize everything. Oh, that's it. The thing is, I do first ones for content and first ones specifically doing centralized for you. But the thing is, he doesn't use headphones, so he doesn't get any artifacts up there. It's working for us. We're learning most of them. I've been listening to on the phone. I think there's a lot of muting involved. No, it's not muting, it's the editing. That's easy. But don't you what would use some audience? It's called German magazine. Not so small paper. And now they're online content podcasts. The podcast is so crappy. It's not enjoyable to listen to. Which one do you actually, I've listened to some US news, like also journal, 15 minutes update. You're the first.
Is anyone here, Johan? B?
No, he said it was going to be a little late, so he might come in like an hour down. I was talking to him via Telegram.
Maybe I mean, there is one guy that we both know from Berlin.
He's good. He's going to be late.
Is he from Berlin?
I don't know. He said like an hour to an hour and a half. But he's going to be at the Bitcoin meetup that is happening at 7 o'clock today. Which, by the way, I'm excited also.
Yes. This is something where we can all move afterwards.
So 2:30 should I?
Yeah. Is there anything on the chat also? No.
I don't know.
Greek is also not there, and there's also not. Okay, then should we close or probably to not disturb others? Then I can say it also here if somebody is watching us. Welcome. This is Wizard Amigos. We organize code camps and meetups. Everything is run by volunteers, so it's basically a group of people who are trying to get more people into coding, to inspire them to start learning maybe JavaScript, crypto, peer-to-peer web, entrepreneurship, and basically more alternative ways of living to adapt to the future. Today we have a couple of lightning talks, and I would like to thank Claros also for covering our event costs, and also Chris and Jonathan, they also chipped in some little donations, so thank you. So we will basically have a round of talks, and then also like some hacking or like just chatting. And I don't know, I was thinking like we could start with talks, but because we're a smaller group, we can even like introduce ourselves so that we know who we all are. So my name is Nina. I am currently a contractor with Ethereum Foundation, where I'm building tooling for people who are building Solidity smart contracts. I started coding 7 years ago, and before that I was a political scientist, startup, marketing, everything person. So then I switched to coding, and I'm doing this. So do you want to go next?
Hey, my name is Alex. I'm working remote for the last couple of years, and I'm also working actually with Nina on the same project currently. And today I will also try to give like a little presentation about remote work and a future of work, how we would like to see it. Yeah.
Hello everyone, I'm Fiona and I'm working a project with Nina and the Alice teams and as a remote worker and I'm designer for a web app and user interface and Lacey.
We didn't even mention the name of the project.
Okay. Hi everyone, it's Chang. I come from Taiwan also, and I'm also a developer. But now I'm working parity team for Polkadot software, related something like yeah. And before I maintain 2 Ethereum fund in Taiwan, So now also maintain the Ethereum mining fund related or something. Yeah.
Nice to have you here.
Hello everyone, my name is John. I'm an system engineer and I'm first time to join this meeting up and I want to understand the blockchain question. So let's
I know you've made the part for this.
Hi, my name is Jonathan. I like to dox myself on Twitch every once in a while. I'm just curious, so I'm learning coding.
Hi, I'm Jatin. I worked in an IT company for like 3-4 years in India, and then I opened the company which deals in teaching machine learning, and also we take projects regarding machine learning.
Hello, my name's Chris. I've been in the Ethereum space for a while. I used to work for a company called Ethcore, now known as Parity. I used to work for Digix, and now I'm on the Ethereum Classic website.
Hello everyone, I'm Clément. So I'm working at Keros, where we've made some dispute resolution system for decentralized applications, and we're gonna see a bit more later.
Hello, I'm Martin. I'm a software engineer and project manager in the telecom world, and currently studying MBA in Taiwan, where I met the wizard Amigos in a meetup about blockchain and Ethereum, and this is basically one field of interest I want to explore more and try to contribute to those meetups where we are attending.
Hi guys, I'm Fred. I've been a developer for some time. I worked on hardware wallet, but recently I moved on and I started working with Autonomous, who does legal wrapping for blockchain companies. So it's essentially spawning companies out, and I'm really excited about being here with you and talking about hardware wallet and just in general how all the way to how the addresses that you transact in crypto work. I think that's it.
That's cool. I mean, now we kind of feeling a little bit cohesive. I wasn't aware that we have so many parity people. I mean,
Yeah.
that's really cool. Because I would like this to be open. I'm not like a maximalist or not even just blockchain person. So I love it. It's actually covers right?
I'm a database guy.
So I'm passionate about literacy, and I think like remote work and get people to empower the future of the world. It's what I'm for. So I don't know. Do you want to, Alex, maybe share something about Wizard Amigos? Like how did we start, and like some thoughts about the future of work? I mean, we're all anyway like there already, but maybe or is that actually a remote engineer or something? Yeah. Getting there? Or you're yourself, like you're yourself employed? Okay. You don't have to be based somewhere. And you're a parity anyway, so.
No, I just
No, but you work from home, right?
I use the phone space.
But you can be wherever. And you also? We will get you there. Cool. I will probably jump around and record a bit, so sorry. And honestly, we kind of set some talks, but if anyone else feels inspired to share something, it would be awesome.
Alright.
We don't have a mic for like here, so we have to speak louder, I guess.
Oh, okay.
No, this is for the Twitch channel.
Maybe let's see if it works.
This cable, yeah, it's
Oh, yeah, it works. Okay. Yeah, so maybe you can tell a little bit about the background of Wizard Amigos and how it all started. So basically in 2013, when I was actually still working for companies, we were thinking it would be cool if I could like start my own thing and maybe do freelancing or even like bootstrap my own organization and work together with others, but I don't want to have employees and I want to do it remote and I want to do it like very different, but like I don't know how to get started, so maybe let's start organizing a meetup and find people who are like-minded and maybe discuss things and maybe we can figure out how to do those things. So one of those things where we were working on our own was creating like an e-learning platform for a Serbian government, for a local city in the context of an election. And in 2015, while we were also organizing those kind of meetups, there were a lot of refugees. We were back then in Berlin actually, and there were a lot of refugees came to Berlin. We thought like, hey, why wouldn't we use this e-learning skills and our skills to help them and build a platform? Because with locals, the hard part was everybody who came on our meetup and we discussed those ideas, they had a job. So nobody was like really willing to like say, oh, this sounds all great, let me ditch my job and let's join and start something new. But when the refugees came, we thought like, they are anyway starting new, so maybe we can introduce them and if they like it, maybe they would join us. So we tried to teach them some coding and help them with those ideas, and kind of they were inspired. So we thought like, hey, inspired by refugees coming to Berlin because many of them were economic migrants, why would we go around and figure out if we can find communities that would start to learn about remote work abroad and start without having to come like half across the world to find a better life somewhere else. And that kind of worked out, and we had like now a couple of chapters around the world where we meet with people and they all run their own local communities and learn. And we were thinking, how can we make this like more systematic, so that basically all these people, we have like a chapter in Nigeria and also in Taiwan, that they kind of collaborate more. So we want to build an app and we are still in the progress, and the idea was that we would make maybe some online learning app, but it should be kind of decentralized. So we don't want like to make this one platform where we have all the content, because there's plenty of them around, but also all these kind of lessons should connect into some kind of skill tree. So like if everybody creates like a lesson, then maybe you could basically discover what are all the lessons out there and how they relate, and then you can jump around and learn them. And we're kind of a little bit inspired by the Super Mario world, where you basically jump from one lesson to the next and it's all connected. And so we thought maybe we can try to build this, and it all started as like a little NPM module. It looks like nothing, but basically what it does, we have like a little links in the slides, I can share them later, how you can create your own workshop. But what it does, once you have to create one JSON file. We started, it's not done yet, a little in-browser form where you can fill out the JSON and then it generates you the workshop. And what this means, it basically only creates this JSON file, and that's all you need to do. And then when you do that, you get the entire workshop hosted as one page. So you can basically fill out things like a title and it will display that, or you fill out like an icon and it displays that, and you fill out the chat and that's your support chat that will be used, and you can use Gitter, but you cannot use others. You can fill out many lessons. Each of them have, of course, a title and maybe a video or PDF or slides. Those are the contents of your lesson, and you can have many. So this one has, for example, 17. It's very tiny, you can't see it probably, but and then once you have a lot of those lessons, you can basically just learn through. And of course, if your lesson is about a certain skill, like for example, you want to teach Solidity, you can embed a tool where you learn this. So why is this all important? So when we have the community and they need to all learn the stack or certain skills so that they can work together with other people in the community and they can all work as a grid of independent individuals, all self-organized and entrepreneurial. So if you create many of those workshops, and many organizations and individuals did already to teach all kinds of things, the data is owned by you, it's hosted on your domain, but you can also in the JSON define which workshops are prerequisites, and those might be hosted by you or other people, and you can jump to those. So it basically, you get the curriculum, you can see for this particular one what are the prerequisites and what can you learn after, but it's not all just hosted by you. It might be though. You can of course maintain like an entire subsection of the skill tree if you want to make many workshops. Now the thing is, if it connects in this skill tree, you can explore that and click and open and learn. We also have another thing that we're working on, an extension for this workshop. So every single workshop would define like a dependency and how much they are willing to share with them, and also what they will earn when somebody who learned the workshop would try to do tasks. So we already outsource and work with other people, and we pay them, and it's all remote. And the idea is we have all of this on GitHub, and we have individual issues, and of course some of them can be exercises, but some of them can be real tasks. And we could display next to a particular workshop all the tasks that are related to the knowledge that you learn in that workshop, or the prerequisite workshops. And then when you click, you do them, and then once you finish, you get of course paid, but a fraction goes back to the workshop maintainer, and of course also the prerequisite workshops. So like the entire sub-ecosystem of people who do that, they can get paid. And that's kind of how we try to approach that. And now let me quickly switch, because like the normal work life is kind of, I mean, everybody knows that, like it's pretty corporate and it's not remote. And yeah, you can climb that ladder, but I mean, the thing is, everything will be, technology will be coming, everything will be more connected, and things might change like a lot. And either these changes will just happen to you, or you can try to actively design that a little bit. And in order to do that, we will need to decide how can we kind of work together. Will it be all organized by the big corporations that just do it all for us? Or what about we as individuals who are so connected and can use all these tools and have all these skills? Maybe we can connect to each other. But everybody has maybe their own idea how they would work, and that's nice, and that's all possible. But like still, in order to make that work and not have it all end up in chaos, we somehow have all these real situations, like some of us like right now sit here and work, but we need to kind of think about how can we connect all this and work together so that these kind of individual work situations can exist in parallel. And that means also how to share the results that come from that work. So of course, if you have like a very structured approach, you see like all these people have very different work relations and different tasks, and usually as a remote worker, especially if I'm employed, I think about myself and I just do what my one client, which is the company that employs me, tells me to do. But now to me, actively reaching out to peers and making new connections and think how can I extend this, and all in a structured manner, that's difficult. So we were thinking, like, because we are also working in the blockchain ecosystem, maybe we can even use smart contracts, and then once we come up with new ideas how to work together, maybe join new projects, we can even use those techniques to set things up in a way that is, even after we met just once and then we moved on and maybe we only talk remote, still things are reliable because we use the tools that we have to support this. And then all these individuals with their individual superpowers need to come and have a smart contract that they can work in crazy ecosystems, and still everything works out because we're supported by this new technology that we need to use for this. But of course, once we are in this complex ecosystem, we want to have the same kind of benefits that you maybe have when you are employed in a company. Like you have maybe paid holidays or sick leave and all kinds of things. And maybe if enough people work together, and I mean that's more like long term, then we can also get there, because smart contracts can solve this too. But yeah, then maybe we can work together and we have it really structured, and everybody of course is their individual person going around, but still the smart contracts help us to make like a network of people that can work together. And actually that looks like a little bit abstract, but actually in reality we already sit on our computers and we use Git version control, and we have all this and and discussions, so in a way we already start this. I mean, that's not yet smart contracts, but still even non-programmers have tools that give you version control and this kind of workflows. And also tools that we use, like it's not only GitHub, it's like online editors, it's like Hangouts, where we basically can talk remote in a team, and we can have that regular, and you can have chat rooms, and the chat rooms link you and show you all the commits that you do, and you can talk, and we can now have Oracle services or anything that picks up those data points and feeds them into smart contracts. And the smart contract systems, we need to design around that. And that's actually then all of a sudden quite closer to what we are already doing, and it doesn't look so far anymore. And that's kind of my closing slide. So from now on, we have to talk how to bring it further. So yeah, thank you.
Any questions? I mean, we can later do discussions, but if somebody has a question.
Maybe it was a lot also, I don't know.
Okay, question. So how do you use smart contracts?
So how do you use smart contract in this kind of ecosystem?
I think it's not easy. I mean, of course, depending, like for example, we talked and worked with a project that's called Gitcoin, and they already pay bounties based on some work that people do, and so this is kind of the straightforward part. But of course, when you want to think of paid sick leave or something, that's not at all straightforward, and a lot of people will think about how to do that. But like a simple example would be Gitcoin. So I basically do my work and then I get paid in crypto on Git. But I think some people also, they work with how to create a legal form, like a company, or maybe if you're a freelancer, but like rather a company, you can use the blockchain to open your company. And I think maybe he will talk later a little bit about this. But yeah, definitely it's a hard question. And yeah, I hope we'll find some answers. And explain what Gitcoin is able by writing more smart contracts that maybe connect to that as a base and do more on top of it.
Does your vision only include software development and designers, or people who can work remotely, or how to include non-related people into?
Right. Yeah, I mean, I have like a very particular view about it. That means that in the future, like basically in the past, let's say like a couple of hundred of years ago, most people probably could not read and write, and maybe the priests could, or whatever, like some lectures, and they were teaching. But like I think in the future that will be the same with programming. So that's like a new literacy, and I think all the jobs, I mean, a lot of jobs are already knowledge worker jobs, so people work on their computer even if they don't do programming. And maybe blockchain will become the new Excel. People will use templates or whatever to use that. And I mean, there will be self-driving cars that are coming sooner or later. There will be drones, and Amazon might do drone delivery. But I think Amazon will also probably then allow you to rent a drone on demand and offer APIs. So if I can rent a car or a drone on demand and have some robots, all of a sudden, instead of just making apps that are purely software-based, I can make the entire supply chain where also cars, ships, anything that can be self-driving, hired via API, can be integrated into an app. So whether it's food delivery or I don't know, any kind of job could be done. So I think everyone would to some degree sooner or later learn programming and use those tools to extend their existing programming job. But eventually even like a hairdresser might buy one or a couple of hairdressing machines and then write a code and like the machine will do the haircut like 1 minute, and it like it's crazy because she designed the robot to do that. I mean, that's probably not gonna happen so soon, but I mean, theoretically, in the long run, you know, even that could happen.
So most people would transform into from your before you did your now you have machines and you need to learn how to administrate and orchestrate machines.
I think entrepreneurship or businesses would be you make you program a mashup of existing services into a new app, and if people start adopting that app, then cool, it's a new working business, and if not, then you pivot and you create the next one. And this is just what you can do all the time. And maybe probably kids, they learn in school. In the UK, they do this since 2014. So when they're like in their final years, they will probably all make apps and talk to each other and show that. And like the best ones will maybe be adopted by the market, and then that's how it goes. Like it will be very. I imagine it to be very different, but it depends also how fast do people become literate. Very few people will decide most of this stuff. So yeah, I hope more people will learn programming.
So, oops, we lost the cap of the microphone.
Probably wasn't so loud.
That's okay. Sorry if it's loud. Okay, so we move to the next step.
Let's see if I can take this somewhere. So guys, this is a presentation that I haven't done in maybe 7 to 8 months, and it is pretty. It goes through. It's pretty much crypto 101. So some of it is going to be a rehash, but at the same time, it's the opportunity for you to check your knowledge. Say something. There's something wrong. I think at some point there's one derivation that is off that I haven't corrected since, but everything should be pretty much a good jump into crypto. And by the way, thanks for being here. Thanks for doing that type of small work, which is where it really all starts. Not everyone knows everything about crypto, and specifically like all the different types of crypto blockchains and algorithms out there. So yeah, originally I started working on wallet. I was at Coolbits for a little over a year. They do hardware wallets. I'm sure you guys have seen the Trezor, the ledgers, and so on that are all around. The way it can be either based on the protocol, and that's more on Satoshi Lab / Trezor, or the hardware side, which is more ledger using secure element chips. So secure element chips are highly secure and tested chips that are placed into the card that are not connected. What happens in the hardware wallet is that you connect to the secure element chip, the secure element chip does the signing, and then it sends back to whatever tool you use to relay it. Anyway, let me go back into this presentation. So crypto wallet, let's see how it works. History, an interesting thing that Alex just pointed out. Back in the day, a lot of people didn't know how to write. So encryption, if you want to push back to where it came from, you can go back to antiquity and the Greeks. And so what they used to do is they have, I think it was called a side teal. They wrapped a piece of leather around a specific diameter rod, and only if you had the specific diameter rod were you able to actually decrypt what the message was. Right after that, Roman Empire, you've heard of the Caesar cipher. Caesar cipher is you take the letters and you just shift them by a predetermined number so that you get a scrambled looking message. And that's where we get the Caesar cipher name. So the reason why that works so well in the Roman Empire is because those people did not know how to read. You know, when the Roman Empire was fighting people, the barbarians, the few that knew how to read, you know, they'd get that weird message and it was scrambled. Like there was no way they would actually decrypt it. So that lasted for a long time. Let's see what I have. Yeah, so that's the history. I think I can probably click back into this because it has a good visualization, so you can see where the history comes from. So that's the site I'm talking about. You can see how it's wrapped up. You have the numbers. This is a cycle where you shift the letters by so on. Then you have more complex version, and then you go into like the really fun stuff like the Enigma machine, which was super interesting to look into. You have the imitation game that
describe some of how. So the Enigma machine was used during World War II by the Nazis to send messages. It was a combination of an algorithm that evolved. So for example, if you pressed F, then let's say the first time you get B, and then the second time you pressed F, you get like Z. Like it switched around. It was an evolving algorithm that was ongoing. It wasn't a simple Caesar cipher that shift by one. So as you kept going, that was 1950, 1943, we go into the computers, 1960s, then you go into data encryption standard, DES, and then you go into AES, and so on. Encryption standards really get to evolve and go and build onto themselves to create what we currently, TCP/IP, HTTPS. The internet right now is powered by encryption and really goes to keep everything safe. Let me go back in this presentation. Bitcoin, we're going to go skim over that. Interesting concept, consensus. What is consensus? It's coming together. It's deciding, I agree on this. Hashing, what is hashing? It's the one-way process of given any input of generating a set output. So you've likely heard of hashing and address generation in the case of Bitcoin because it's the easiest to learn. And address is the hash of public key. So you always hear like public key hash addresses, which is which. And that's really what it gets down to. The signing, it's the digital validation of the originator of a message. So keep in mind, we're talking messages, we could be talking transactions, it's give and take. Based on the hash function, it's cornerstone of digital communication, and then blocks, it's the content with the data inside. Blockchain. Okay, so going down into the math of blockchain. It's been a while. Wow. Protocol implementation are complex, but the way that they work is that they build on mathematical foundations of extreme purity. An example, for example, prime numbers. You go into prime numbers. They're simple. What is a prime number? It's a number that is divisible by himself or by one, and that's it. That's like pure mathematical property. So even though Bitcoin specifically is based on ECDS signing algorithm or ECC, elliptic curve cryptography, I'm going to be talking about RSA key generation, which is using prime numbers because they're easier to explain. People understand prime numbers. As you have those mathematical strong foundation at the base layer, you get to build more complex sets of protocols that create complex behaviors, like exchanging money or smart contracts. All of those build on top of base purity. So it's satisfying to be able to dig down to the core level if you want to understand a little bit how it works. So we talk about hashing. When you think of encryption, you think of a message that you can encrypt and that you can decrypt. Here's the thing, hashing is one way. It's not something that you can decrypt. And that's something a lot of people do not get. Hashing is one way. So you can take any input and it's going to give you a reduced set of framed output. So in the case of Bitcoin SHA-256, you get 256-bit output. That's it, no matter whatever you feed into it. If you feed like 1 gigabyte, you get like 256 bits that are output. And if you feed the same entry, you get the same output. It's repeatable. It's something that is easily verifiable. So for encryption, we do cryptographic hash function. We want some desired qualities. We want to limit collisions. Because you have an infinite set of input, it's mathematically feasible that there are collisions, multiple inputs that give you the same hash output or the same digest. We want them to be computationally efficient, so easy to generate and validate, and collision resistant. So, and we want them to hide the information about the input. Most of those are interrelated. You can guarantee them, but you can try to design for them. We talk about keys a lot, so you have public and private key, and really down to PKC, public key cryptography. So you get a set of keys, public and private. And the way I like thinking about it is that they really work like magic stones. So I don't like the key analogy that much. I like the magic stones because I have two magic stones. Whatever I encrypt with one can only be decrypted with the other. And the way they work is leveraging one of those strong mathematical principles, in the case of Bitcoin, elliptical curve, digital ECDSA, or other key generation mechanisms. So keys are digital construct abstracted as keys. The intent is to encrypt, decrypt. It's a one-way functionality where one can decrypt a message encrypted with key A using key B. So if you encrypt with key A, you have to decrypt with key B. And that, as in, if you encrypt with key A and you try to decrypt with key A, it's not going to work. And that's what we call that an asymmetrical relationship. It's not a symmetrical, it's not just a simple I encrypt with one key and I can decrypt with it. It is asymmetrical. You have to use the other key to decrypt. That's a basic example from Wikipedia. You can see you have Bob that wants to send a message to Alice. Hello, Alice. How does he do it? Alice has published her public key. And she just arbitrarily decided, I'm going to make this one public. Bob sees Alice's public key. He sends the message, he encrypts it, and let's say he sends it, and he knows that the only person that's going to be able to decrypt that message is going to be whoever has the private key or the matching key. So in this case, Alice gets the message, she decrypts it. So I'm going to be talking about prime numbers, mathematical properties evolving into public key encryption through number theory. So prime numbers only divisible by themselves or by 1. All positive prime integers are made up of primes. That's called the fundamental theorem of arithmetic. So if you take any number, you can break it down into a factor of primes, as in like 1 times 3 times whatever. By multiplying two primes, and prime numbers, keep in mind, all positive integers are made up of a factor, but a prime number itself is only divisible by himself or by 1. So it is its own set of prime. Like the prime number is only divisible by himself. So therefore, you take two prime numbers, you multiply them, and you get a semi-prime, or I forgot the actual term, which is non-prime because it has like two factors, of course. But those two factors being prime means that it only has one single possible factorization, the two numbers that you use to compute them. Figuring out which prime numbers pair was used to generate the extremely large number is prohibitively expensive. And this is called the integer factorization problem. This is what you have, this is what I forgot when it was in the 60s or something, where prime considered a matter of national security. If you knew prime numbers, you could write them in combination with other ones, and it's crazy when you think about it. Proof of work? Kind of. Yeah, I mean, it goes close to it. So you can get it as two sides. On one side, you have the two prime numbers that you used to compute the third one, which is the semi-prime. So those are essentially public and private key in this case. But there's a lot of edge cases. For example, can a computer break a public key and find the associated private key by sheer computational strength? Yes, but it will take a really long time. DigiCert in 2010 asserted that it will take 1.5 million years for a basic computer to hack 768-bit RSA, 432 digit long. So, and prohibitively expensive, the solution space grows faster than the input space. So if you try to look for a specific solution, the bigger the, if you go back in the hash or you try to break the bigger the hash, the more you check for other possible options. And you know, in that case, you think, well, can I just make a list of all the possible factors, try different combination? You can, but again, there's an infinity of prime numbers in modern computers. Right now, we're talking about prime numbers. Again, ECDSA, elliptical curve, digital signature algorithm, which is like Ethereum, Bitcoin, and so on, is like another beast. Will future computers break encryption? Computers evolve with technology. It's pretty much baked into encryption. You have to continuously evolve your encryption. No matter what technology keeps going forward, there's no security that is guaranteed. If anybody tells you there is, it's wrong. Quantum computers, you know, can they break encryption? So what quantum computers do is, instead of, if you try to break an encryption, in this case, the rate of speed at which you try to break it, so the solution space and the input space essentially converge. They work at the same level. as far as we're concerned, I mean, I don't believe in the whole quantum supremacy and everything. It's a gimmicky right now. Right now, the biggest quantum computer is 72 qubits. Last I wrote this, which was by Google. So every qubit scale bigger than the next one. So 71 qubit is much smaller, like 10 times less strong than 72 qubit. But the expectation is that for 2048 RCA will require a 4,000 qubit quantum computer to break. So key security can be upgraded to quantum resistance. We have things like lattice cryptography, and there's other ways of designing an algorithm to make it so that it's quantum resistant. This is encryption. You have to continuously upgrade the protocol. Eventually, there's like some security breach. So quantum computers, I think, is great. They're pushing encryption forward. Security fades over time as technology improves. And going into I've been rushing through. Sorry, I'm going to take a second. Do I have any question, by the way? Because yeah.
Crowd computing. Like you just take the public, everybody, you have 1 billion users outside, and if you try hacker-like to integrate it to do the crowd computing, can you hack the most valuable Bitcoin address with crowd computing?
Anybody want to try this one? I can see it. Yeah.
So assuming computer, so no quantum computer, every time you add 1 bit in your key length, you're gonna double the time people need to break it. So imagine you need if you have 10 bits, you will need 10,000 computers to break it, to have some high likelihood of breaking it. You just add 1 bit, you go to 11, and now 2,000 of computers to break it. So the thing that the amount of computer to break it, it goes exponentially to the amount of bits you have. So every time you add one, you ask the attackers to double the amount of people they manage to gather to be able to attack your system. So you can see that just adding something like 100 bits, even if the whole world were to gather to break your encryption, it will not manage to do it.
Yeah, sounds reasonable. Right there. Yeah, I don't know how we're going to do this with this.
Walk closer, I guess. So one of the downsides of encrypting my data is that it's basically, well, it's the upside and the downside. It's unreadable for anybody who doesn't have the cloud key, as you say. But today what we do all often is we use cloud computing to compute stuff for us, right? So what I would like sometimes to do is upload my data somewhere and then let the number crunching or whatever I'm doing to be done by Amazon or Google or whoever. And today I'm aware that there's two techniques that people try to apply in order to still be able to leverage cloud computing and still use encryption, which is homomorphic encryption. So I can encrypt my data in a way that you cannot read it, but you can actually perform some computation. You can do some additions, add two encrypted numbers to each other, send me back the result. You don't know what is the actual sum, but I can decrypt again the sum you have done the actual computation. The other one is, and I think you were at the beginning, hardware security, like trusted computer platforms, Intel SGX, like this type of. I don't really own my computer anymore in a sense. My computer does stuff, but I can't extract information out of it. Do you have any insights into if there's any advance in that space lately? Because I haven't been following this very closely, but I'm quite interested where people are moving or where you feel this is moving.
So I personally don't, I was in hardware wallet for a year. I mean, this is just an overview. I haven't dug into it. If anybody is more aware of that, welcome to stand up. But I think there's a lot of interesting projects. I'm really curious right now about IPFS, for example, which I know nothing about and I really want to dig in. I don't know. No, I think at the protocol level, there's very interesting things that are happening, and it's impossible to track of everything.
To understand even at what level it has reached, right? Yeah. Okay.
Yeah.
Cool.
Sorry. Anybody else for intro? Okay. Yeah. Yeah, it does not be a question, but it's interesting.
Yeah, I had a question about like collisions. and why they're considered so catastrophic if there is one found?
So collision means that someone is going to generate the same, pretty much the same public-private key. It's like at that point, somebody else is going to have your key, is going to be able to sign or get access to your wallet.
But like, if they find two random strings that collide, yeah, that's different to finding my private key. So why is it still considered catastrophic if they find two strings?
It's just weaken security. At this point, if you have two random strings that map, it doesn't really matter because of course it's key generation that is significant. But the fact that you know of a collision means that you can try to design an algorithm knowing that there's like one weakness in I think it's called like a long attack or something like that. Once you have a collision, then you can start building around that to try to figure out a scenario where you might take advantage of. It's so SHA-256 doesn't have collision as far as I'm aware. Like they have yet to find one since they started using it. So SHA-1 they found a collision, John?
SHA-1. There's a great shot here.
Collision. So what you expect of hashes is that there to be one-way function. So you have A and you hash A to get B, and from this B you cannot get back A. But if someone gives you A, you can verify that this is the A which is leading to B after it's being hashed. So simple example, we want to do a blind auction where we're gonna say, okay, I'm okay to pay 10 on this item, but I don't want the other bidder to know that I'm ready to pay 10. So we have one phase where we make a commitment, so we submit the hash of our bid, the amount we are ready to pay, and after we reveal this value, it's hashed, so everyone can verify that the value we have revealed corresponds to the value we have hashed. Now imagine you have collision, and you found that there is a collision between 10 and 1000. That means that I can commit the value which are gonna lead to a B, and this can be either 10 or 1000. And then after that, I can reveal one or I can reveal another. So in this case, I'm not committing because I still have the choice to reveal two values. So that's why you don't want collision to be practical. Another example is signing something. When you are signing in practice, you don't sign the whole message, you just sign the hash of the message. So now if I find a collision and I have a message which say, yes, I really like this idea, let's do it. And another message will say, no, this is bullshit, we should never do that. And I sign one of these messages, and someone see that yes, this, and he finds that it collides with no, this is bullshit, we should never do that. He can then show to people that I signed the message, this is bullshit, we should never do that, why I signed another message. So you can trick people to think that I have a message that I haven't signed. So that's why collision are really problematic.
Okay, let me see where we are right here. So asymmetric key encryption means that you have to use the other key to decrypt or to encrypt, and you can use that also as a way to sign. Knowing the other person's signature, you can get, knowing the other person's public key, you're going to be able to sign a message specifically to them, and they're going to be able to verify that you're the user that signed it. So very interesting mechanics that evolves. You know, more layers of complexity wrapped up. Sorry, by the way, for this tiny script. It's really not meant to be shown. But yeah, seeds address generation beyond the scope of this. So you should understand public and private key pairing and how they enable both signing and encrypting and decrypting. If you use one key to encrypt, the recipient has to use the other key to decrypt. That's why you put a key in the public space so that people can try to encrypt something to you that they can see with your public key that only you are going to be able to decrypt. And that's public key cryptography. That was a big thing in the 1990s, and it evolved into crypto right now. Yeah, let's go into okay, so a blockchain example. This is like an example of the Bitcoin blockchain, for example. You can see that the two sides are slightly different, yet essentially they're the same. There's a bunch of hex right now, and this is, I forgot what it is, like MD 160. This is Jack Bob, you can see the numbers. This is Alice, the same. I mean, you have the hashes of the keys that really dictate what the addresses are. And that's what the blockchain is. Long list of transactions. Distinctions, centralized, decentralized, distributed. So you hear those words a lot. What they mean is often hand-waved. So you can see centralized all go into one point. It goes to one company. Decentralized means that it might be data at multiple servers, but it's still not connected to everything. And the distributed means that everyone essentially is connected to every other possible nodes. So the nodes are the bubbles in this. How does the network? Yeah, we consensus. How are blocks chained? I find that's another concept that a lot of people skip or glaze over. So you can see on the screen you have a Genesis block. There's a hash, and remember the hash is the one bounded output of whatever input you put in. So what you do, and the way I like thinking about hashing is it's kind of funky. I'm sorry for the vegans and vegetarians out there, but like you take a cow and you put it into a blender and you press. That's hashing. It's one way. You're not going to be able to get the cow back together. I mean, you could, but it'd be computationally really inefficient.
It could be a salary.
So that's hashing. It's one way. So what you do is you take a block, you press it to the blender, and you get this weird hash. And that hash, you're going to like plop it into the next block, and you're going to say, this is the hash of the block that came right before you. And that hash, if you were to change just one digit, or like changing anything within the block generation, like if you change just one thing within Gen block 1, then it changed the hash completely for Gen 2. So that tremendous repercussion, that's the chaining. That's what it is. Once you have that, you pretty much guarantee that this block came after this block, came after this block, came before. So, yeah. So that's an example of an attacker that tries to change a transaction within block 2. You change something into block, I don't know, so change this hash, yeah. So you try to change something into block 2, what used to be 6BQ1 right here as a hash, because the attacker actually changed the transaction, it changed the entire resulting hash of this. So the actual hash now becomes H62Y or whatever, and then you can see there's a discount before because the block 3 had always been generated, and you can see the hash, and it's the previous hash, which is the correct 6BQ1. But now you can see there's a disconnect because the two do not match. This one that was just modified by an attacker does not match the hash that the block 3 lists as the previous hash. So that's where you have the validation of the chain. Someone can clearly say, like, something went wrong, I'm not going to accept whatever block comes after that, blah, blah, blah. Yeah, so this is the part where I like going a little bit more into wallets. I don't know if we care too much to go into it. They're interesting. I really like it. You have the hot wallet, cold wallet, the easiest entry into this. Hot wallet, what it means, it's connected to the internet. So cold wallet means it's not connected to the internet, meaning even though I can transaction with my wallet, my Letras or whatever it is, by itself, it's not connected. So this is like an example of my wallet. I'll have some Bitcoin, some Ethereum, some Ripple, but at the same time, this is never connected to the internet. What I do is I use a platform that is connected to the internet to connect to it. In this case, I use a phone, I use a Bluetooth connection, there's Bluetooth pairing, bonding. This is connected to the internet. I prepare the transaction right here. Using the Bluetooth bridge, I go over to the wallet. I have a physical button on this to validate the transaction. So the signing is done right here on the wallet. It relays back to the computer or to the phone, and then it goes to the blockchain. That means that, and the distinction is very finite as to how it makes it safer than just storing it on your computer or on like a web wallet or something like that. Because an attacker that knows that I have Bitcoin is going to try to get my wallet. if I keep it on the website, he can like keep brute forcing it and try to break the website. That's connected to the internet. And the moment he actually makes it, he gets my funds. But this, it's literally not connected. And you can try to break into my phone or something. It's different also. But this is not connected until I actually establish the connection. That's the cold wallet. So I can put this in a bank. I'm not worried. It's the early entry into it. Do you guys have questions, concerns about like wallet before I dig a little deep? I have like 5 minutes left, tops. Okay. So, yeah. Wallet keeps track of your transactions, technical detail, generate and receive sent addresses, prepare your transactions, connects with the node network to update the total in your address. I mean, the earliest wallets were shit. They had bugs. They were really bad. Like, they reuse the same addresses. Like, even today's wallets are really hugely inefficient, like, and really bad. I've looked. I'm glad that we're seeing some progress into this. Yeah. So, I guess there might have been some unknown here. I don't know what this is. I'm not going to dig into it. Wallet right. No, it sounds interesting. The wallet is where you keep your coins. Yeah. What is a wallet? I think that one is interesting. The wallet client is the tool or interface used in conjunction with your master private key to communicate with blockchain. Again, a wallet client. Client is whatever interface you use. But what is a wallet? You know, what is it? The wallet is pretty much like your private key. It's whatever tools you use and make it so that you can sign and bundle the transactions so that you get the transaction on the blockchain. That's your wallet. So they take many forms. Some of them are more secure than others. Some of them are hardware. Some of them are web wallets. But use a wallet client with your private key to send transaction, and that is a wallet. Yeah, you can think of it, an analogy will be like Outlook, which is an email client, for example, where you can connect and plug in your Gmail into other things. And this is a client. Okay, moving on. Transactional use case, how to obtain coins, create your wallet. Let me move on to this. Yeah, you often hear people talk about storing currency X or Y on the wallet. I guess it's not technically correct. I'm finding y'all as I read those slides. I haven't looked at it.
I have one more thing about the wallet.
Yeah, please.
Let us hear your beautiful voice, Jonathan.
I think that another interesting thing to note about the wallet is that essentially with cryptography, you're dealing with the universe of possibilities of numbers, and when you're using a wallet, it's basically creating a filter to focus on the private keys that you created, and it filters the vast majority numbers and allows you to interact with just the private keys that you're interested in. So then when something happens on the blockchain and you want to be able to monitor your transactions, it's looking for those changes that are happening publicly. And because the space of possibility of numbers is so vast, it's impossible, well, it's feasible for anyone to know what you're looking for, because they would have to look through everything, and that just takes more heat energy than the universe can offer.
I mean, I'm sometimes thinking, like what you just said, isn't that your identity? What's the difference then between the wallet and identity? Because if this is a set of private and public key and you're signing transactions in a way.
Discussion right now, you have the FATF that just issued guidelines on digital identities, I think earlier this month. Everyone is trying to build their own version of digital identity. And it's so complicated, you're setting foot in like a snake pit. It's not good. You can use it as an identity. There's many different ways, but which one is recognized really depends on what jurisdictions you're working with. And you really quickly get into the political spectrum and the jurisdiction legal side of things, which is fascinating, but it's all, if you look at it as a bigger picture, it's all a sham. You know, they're all trying to say that they have jurisdiction. Truth is, if you get down to it and you go into the numbers, you know, it's math. It's a mathematical truth beats take your time. I mean, as far as you look in my book, but I don't know. I'm hoping that we do some progress into digital identity. I know there's going to be a lot more coming on in the next few years, but wallet, I have 2-3 minutes. Let me go into, so BIPs, I think they're fascinating. I'm doing a side project right now to try to explain how they work. BIP are Bitcoin Improvement Proposal. You're seeing the same chains. You have the Cardano ones, the Ethereum one, and so on. So what they are is a set of rules that developers have decided that they will comply by and they will adopt to try to make developing on that blockchain more streamlined. So in the case of wallets and key derivation, we're talking the famous one are BIP 32, 39, 43, 44, and there's new ones like 70, 75 that are coming up. They're pushed on GitHub. You can go read about it. They're kind of frustrating to dig into because it's not super straightforward. But here's BIP 32. What this one set up was how you derive a wallet. So you have an entropy. Entropy is pure random at the beginning, 128-bit. What you do is you apply HMAX SHA-512, which is how you generate the masternode key, and that gives you one key, one public key and one private key, and then from that you do a CKD, child key derivation, that you reapply using a salt that gives you different ways that you can set multiple accounts, and then you can have wallet chains and then addresses. Every time you expand it, so it grows further out. You can define multiple wallets. So that was BIP 32. There's
the big point there is that obviously before that standard, it wasn't clear or repeatable that every time you would create a new wallet, you get the same address.
Previously, people reused the same addresses. Well, the address reuse also was new.
Address and you wouldn't know which address would be sort of randomized. But with that standard.
Deterministic. Hierarchical deterministic. That was the title of hierarchically deterministic addresses or wallet. I forgot the name. So BIP 39, this is the of the word mnemonics. The word mnemonics were the generated. So you have that entropy that generates. The entropy is converted into a set of 12 words that are then matched up to a 2048 word list dictionary that you then use to generate a seed. And then after that, you keep going. So that was 39. 44 is multi-account hierarchy for deterministic wallet. So you still do the same 28-bit plus the 2048 dictionary to generate the mnemonic seed. Then you get to the seed, then you get to the mask, the purpose, then you get to the coin type, and that's the part where you have recognized coin type that have decided that even though I'm not Bitcoin, I'm still going to comply by that derivation